Okay, welcome to This Explainer. Today, we are diving into something absolutely wild. We're exploring a radical, step-by-step method that treats the world's most mysterious manuscript, the Voynich manuscript, not as a spoken language, but as a purely mechanical code. It's called the Fontana-Luth method, and it is a truly fascinating new tool.
I mean, ask yourself, why have a century of brilliant linguists, top-tier cryptographers, and literally advanced modern AI yielded absolutely nothing when looking at these ancient pages? Well, everyone has always assumed the glyphs on the page are a language, with letters, words, and grammar. But what if that core assumption has been completely wrong for over 600 years? Here's our roadmap for today. We're going to cover geometry instead of language, the mechanical tool, Step 1, prepare materials. Step 2, measure angles. And finally, a practical example where we actually decode Folio 1R. Let's get right into it. Section 1, geometry instead of language, a paradigm shift. This is the core idea that turns literally everything we thought we knew about the Voynich manuscript upside down. Notice the contrast here between the old thinking and this new approach. Instead of reading letters, I want you to imagine a clock face. Every hour has a position, right? 12 o'clock at the top, 3 o'clock to the right, and so on. Now, imagine someone recording pointer positions instead of writing words. The glyphs simply represent these pointer positions and angles. This completely removes the need for a spoken language and replaces it with pure mechanical geometry.
Section 2, the mechanical tool, 15th century engineering. To really understand how this geometric system works, we have to look to the past, specifically to the historical devices that inspired this exact approach.
Take a look at our historical foundation, Giovanni Fontana's speculum. Fontana was a 15th century Italian engineer and physician, and this right here is a documented, real historical object. It's a circular cipher disk. It proves that this specific type of geometric cryptography, translating physical positions into meaning, actually existed exactly around the time the Voynich manuscript was created.
Building on that history, independent researcher René Luth applied Fontana's concept directly to the Voynich manuscript to create a deterministic measurement tool. Looking at this exploded assembly of the disk, notice how it divides a full circle into 16 equal sections. Each section is exactly 22.5 degrees wide, and each sector is assigned exactly one Voynich glyph. No overlaps, no duplicates. This guarantees that no matter who uses it, you get the exact same result every single time.
All right, Section 3, Step 1, prepare materials, your detective's kit. So how do we actually use this thing? Let's get right into the step-by-step guide, starting with prepping your materials. The absolutely crucial point here is that you don't need a supercomputer or a fancy university degree to test this method. You literally just need to gather a few simple physical items to build your detective's kit. All you need is the printed 16-sector Fontana-Luth disk, the official instruction sheet, a standard pencil, and a free digital copy of a manuscript page from the Beinecke Library Archive. Once you have those 4 things on your desk, you're ready to go. Section 4. Step 2, measure angles. Operating the disk. Now that our materials are laid out and ready, let's move to the operational demonstration and see exactly how to measure these mysterious angles on the page. Here is the exact step-by-step process. First, you physically place the center of your printed disk over the beginning of a line of text. Next, you look at the first glyph and identify its dominant stroke, basically which direction does the main curve or line point. Then, you find that matching angle on the disk to identify the correct sector. Finally, you write down the corresponding meaning class for that sector. And you just do this glyph by glyph. So, what exactly are those meaning classes? Well, each of the 16 strict sectors correlates to a specific meaning class derived from the abbreviation system of Latin abbreviations. This table gives us a quick snapshot of how it maps out. For instance, an angle falling in Sector 3 gives you the meaning class for Latin words abbreviated with B or C. Sector 8 maps to words abbreviated with K or L. You aren't getting English letters. You're getting a testable, repeatable sequence of Latin shorthand classes. But wait, there is one massive exception to this rule, and honestly, it's brilliant. There is a specific glyph that looks like the number 8. For 600 years, literally everyone mistook this for just another letter, but according to the Fontana-Luth method, it has no angle and no sector. It is actually a mechanical gear shift. It's a control command, not content. Let's see how this builds our mechanical understanding. Depending on the visual variant of the 8, you must physically shift your disk. If it's a closed, symmetrical 8, you rotate your disk forward by 18 degrees. That's an alpha shift. If the top loop is open, you shift the disk backwards by 22.5 degrees for a beta shift. And if it has an asymmetric tail curving down into the left, that's a full reset. You bring the disk all the way back to absolute 0 degrees. You apply the shift, and then you just read the next sequence of angles under the newly calibrated position. Section 5. Practical example, Folio 1R decoded. Okay, so we have our materials, we know how to measure the angles, and we know how to use the gear shift. Now, let's put this incredible theory to the ultimate test and apply it directly to a practical example. We are going to look at Folio 1R, which is the very first page of the Voynich manuscript. By systematically placing our calibrated disk over the first line of text, we can completely ignore the illusion of an alphabet. We aren't looking for vowels or consonants anymore. We are simply letting the dominant strokes point to our 16 sectors. Let's isolate the fourth word of that very first line. When we measure the angles of these glyphs, they point to sectors 3, 8, 3, 9, 9, and 10. When we look up our table, the angles give us a very specific sequence of Latin abbreviation classes. We get B or C, then K or L, then B or C, M or N again, and finally O or P. Now, why does this actually matter? Well, because in 15th century Latin shorthand, this exact sequence perfectly maps onto standard abbreviations in the Capelli lexicon for words like de modo, meaning in this manner, or domino, meaning lord or master. The geometry successfully transforms into a legitimate, structurally sound 15th century Latin shorthand combination. It's kind of mind-blowing when you see it work. As the researcher René Luth states, this isn't presented as a final, definitive answer that just instantly translates the whole book today. Rather, it's a definitive new direction. He's asking you to try it. He's challenging us to step up, break out of a century of failed linguistic models, and test the mechanical geometry ourselves. If it produces nothing, hey, we know. But if it produces something, it changes history. And that brings us to the most exciting part of this explainer. The method is open. The archives are completely free. Grab a pencil, print the disk, and start measuring the angles for yourself. Will you be the one to finally crack the mechanical code of the Voynich manuscript? The true translation might just be waiting for your own eyes to decode it. Let's get to work.